Assalamu alaikum, dear students. Welcome to the lecture number 4 of second week of Geotechnical Engineering 1. Today the topic of our discussion is types of soil deposits. So let's begin. The soil is produced by weathering of rocks, as we discussed in our last lecture. These weatherings can be transported from where they have occurred, from where they are separated from their parent rock by physical processes to the other places. Okay, the resulting soil deposits are called transported soils. So transported soils are the soils which are carried from the rock weathering place, from where the rock has weathered, and the particles, the soil weathering, the fragments, they've been removed from the rock by various physical and chemical processes, and then they are carried by various physical processes to other locations. Then they will be called transported soils. Okay, in contrast, the soils that stay where they were formed, okay, where they were weathered from rock, from where they were fragmented from rock, okay, that is basically known as residual soil. So if the rock is weathered and the soil remain at the same place, then it will be called residual soil. Okay, but if the soil is being transported from the place of weathering by various forces, which we are going to discuss today, to other locations, then that will be known as transported soils. Okay, so these are mainly the two classes of the soils. In addition to transported and residual soils, there are peats or organic soils as well, which derive from decomposition of organic materials, because their origin is not from rock. They are not rock weathering, but rather they are decomposed organic matter. So we will deal them separately and we will discuss them in the end. So now moving on to residual soils. As I discussed earlier, the weathering of rocks can produce the fragmented pieces, which is referred to known as soils. If they are laying in the same area, then they will be known as residual soil, where they are weathered from rock. Okay, so residual soils are found in the areas where the rate of weathering is more than the rate with which the materials can be carried away by transporting agents. So if the soil is being weathered away from the rock, but the transporting agents is not available, so of course the soil will be lying at the place where it was weathered. So it will be called residual soil. It will be residing at the same place where it was formed, because it is not being transported. The rate of weathering is higher in warm and humid regions. Okay, so in warm and humid regions, rocks, they weather quickly, easily, due to the reason which we discussed in the previous class, compared to the cooler and drier regions. Okay, so that's why in warm and humid regions, where the temperature is more and humidity is more, you will find more residual soils. Okay, so depending on the climatic condition, the effect of weathering may vary widely in different regions, but you will see in the areas where there is warm and humid temperature, you will see more residual soil than transported soils. Okay, so residual soils deposits are common in the tropics. The tropical regions, they've got high humidity and high temperature. Okay, this is also known as tropical weather as well. The nature of residual soil deposit will generally depend on the parent rock. Okay, because obviously if it is being derived from dolomite, it will have more dolomite like properties. If it is weathered from sandstone, it will have more have sand type property, etc. So when hard rocks such as granite or gneiss, which are the hardest rocks, you may have studied them in your geology in second semester, when they undergo weathering, the most of the materials are likely to remain in place. Okay, and the soil deposits generally have top layer of clay or silty clay material, which you can see over here. Okay, so residual soils which originate from granite and gneiss will have a top layer of clay, okay, a fine grained material, below which there will be silty or sandy soil layers. Okay, and underneath you will have basically the fractured rock at certain depth, and then beneath that you will have the sound rock. Okay, this kind of deposit is kindly formed in the Swat region. You may observe when you excavate over there, and the top you will have clay. After some few feet you will start discovering silt and sand, and then when you dig further you will start discovering fragmented pieces of rocks, fractured rock, and then when you excavate further you will reach the sound rock. So that will basically be indication of that as a residual soil over there. Okay, in contrast to the hard rocks, if you have soft rocks, okay, like limestone, which are chiefly made of calcite, which is known as calcium carbonate, it's a mineral, chalk, dolomite, limestone, they can be decomposed. They are referred to as a soft rocks. They can be easily decomposed and chemically altered, so usually they have chemical weathering. So these rocks have large amount of soluble minerals, okay, materials, which are removed by the groundwater, leaving behind the insoluble fraction of the rock, which you can see over here. This is the insoluble fraction of the rock, and this is the fraction of the rock which has been removed by the chemical weathering in this case. So this is the insoluble portion, which you can see whitish in the color, calcium carbonate. Calcium and magnesium carbonate both will have similar kind of color. The residual soil, which is derived from the chemical rocks, okay, by chemical decomposition, possess a gradual transition zones to the bedrock, and the residual soil derived from the weathering of limestone like rocks are mostly red in color. You can see over here they are more reddish compared to the parent rock, okay, because of the chemical alteration. So the residual soils may immediately above the bedrock may have been normally consolidated as well, because this soil has been formed by weathering of this rock, so it has not been deposited by water or glacial movement. So this soil will be usually normally consolidated, which basically means that it will not be compacted very well. So if you build your construction, if you make your building on that, or if you are using this for engineering purposes, you should know that these rocks, these deposits will have a tendency to settle more. They will have more settlement susceptibility, so you will have to basically use them with caution. Okay, that's why we are discussing all these things. You see, these residual soils which are resulting from the hard rock, they will be usually of better strength, and they will have more settlement resistance compared to residual soil which are derived from the soft rock like calcite, calcium, magnesium carbonate, etc. Okay, so now moving on to the transported soils. Okay, as I discussed, transported soils are the soils which have been transported by various physical processes from the location where they are formed to the location where they are now. Okay, generally you will find the transported soils in valleys, like Peshawar is a valley. You find mostly soil over here. There is no rock, but this soil has been brought up by those transporting agents from nearby mountains. Okay, they are weathered over there, then they will be transported and deposited in Peshawar Valley. Okay, so that's why we see soil over here. So transported soils can be subdivided into 5 major categories based on the transporting agent. There are various transporting agents through which the soil can be transported from one place to other place. 5 major transporting agents are usually responsible, which we will discuss in the following. Okay, first is gravity transported soil, which is the transportation by gravity action. Then we have lacustrine or lake deposit. We have got alluvial or fluvial soil deposits, which are usually by running water. And then we have glacial soil deposits, which are deposited in lower laying areas by glacier movement. And we have got Uillean soil deposits, which are basically soil deposited by the wind. Okay, so now discussing them one by one in detail. First of all, gravity transported soil. Residual soils on a steep natural slope can move slowly downward. Okay, if there is a steep slope, this is the parent rock, this is the weathering which has been removed by chemical and water action, which you can see over here, and this soil is slowly and gradually moving downward. okay, which is known as creep. Because of the what? Because of gravity. Okay, because of gravity, anything will move from higher to lower location. So this will be known as creep. It will be slow movement of the soil downward. Okay. Sometimes the downward soil movement is sudden and rapid as well. Okay, which is in the form of a landslide, which you can see in the second figure. Okay, this is also because of gravity. Okay, and then soil deposits formed by the landslide are known as colluvium. The third process will be mud flows. Okay, and mud flows, we don't have like landslide type failure or creep failure in this because of the very high flow of water on the surface of the steep slopes. Okay, the top soil, if it is soft, it is eroded away. Okay, and especially if it does not have much vegetation, then it is eroded away and carried to the lower lying areas. So all these three processes, creep, landslide and mud flows, are basically responsible for gravity transportation of the soil from higher elevation, that is the mountains, to the lower elevation, that is the valleys. Okay, so the soil deposits derived from past mud flows are highly heterogeneous in composition, because mud flows, they take everything on their way, that is vegetation, fragmented pieces of rocks, clay, silt. So they will be mixed, heterogeneous in composition compared to the other types of the soils like resulting from creep, etc., in which you will have one particular type of soil, while in mud flows you will have everything mixed together. Then second, lacustrine or lake deposits. Okay, water from rivers and springs flows into the lakes. You know, you have seen lakes in various regions. They are basically fed by the flow coming in from the nearby mountains. In arid regions, in the areas where you have less rainfall, the stream carries large amount of suspended solids. Okay, the streams coming from the mountains, they carry large amount of suspended solids. Okay, particles suspended within the water. So where the stream enters the lake, granular particles are deposited in the area forming a delta. So when the stream enters a lake, you can see it is basically depositing silty and sandy soil over here, forming a delta. Okay, some coarser particles and the fine particles, that is silt and clay, are carried into the lake, are deposited on the lake bottom in alternate layers of coarse grain and fine grain particles. Okay, so they will be deposited. This is the one of the picture which is being shown from the old lake, because Earth has more than 3 billion years geological life. It has been formed about 4.5 billion years ago. So some areas were lake before, then they were because of geological action, because of the continental drift, etc. Now they are dry regions in the lake, and water bodies have shifted other locations. So this is from the one of the prehistoric lake, you can see, and the soil has been deposited in the layer. Okay, so coarse grain, fine grain, coarse grain, fine grain, they are basically deposited in the alternate layers. Okay, which you can see over here. So there will be coarse grain particles and fine grain particles. They will be deposited in the lakes in the alternate layers, depending on the high flood and low flood seasons. In high flood season, it will be carrying coarse grain particles, and low flood season, it will be carrying fine grain particles. That's why you've got alternate layers. Okay, so two layers basically shows 1 year of deposition. Okay, this is how we determine geological age. So the deltas formed in humid regions usually have finer grained soil deposits compared to those in arid region. In arid regions, they've got coarse grain particles in the lacustrine deposit. In the humid regions, they've got fine grain particles in the deltas or the lacustrine deposits. So you may have heard about Indus Delta. When the river Indus, it enters many locations in the Sindh region, etc. It forms a lot of lake around it in the high flood season, and the deposition in those regions are known as Indus River Delta, and you can see the fine grain particles being deposited in those regions. So they are known as lacustrine deposits, or I've translated Leucostein to lake deposit to you for you over here. Then besides lake we have got rivers as well. Okay, lake is a stationary water body where the water is being accumulated. Okay, while in river the water is in motion. Okay, this is the only difference. So we have got alluvial or fluvial deposits, which are deposition by running water. Okay, alluvial deposits are derived from the action of streams and rivers and can be divided into two major categories: braided stream deposits and deposits caused by the meandering belt of streams, okay, or rivers. So first, braided stream deposits. You see there is similarity over here. Braid is basically this kind of hairstyle which girls usually have. Okay, this is called braid, and you can see this river, it is tangled together and moving across each other, you can see like a braid. Okay, compared to the meandering river, which you can see over here, it's meandering but it is not crossing its path on its way. Okay, so we'll discuss these portions which are over here, the Oxbow Lakes, later in detail. So first, discussing the braided stream deposits. What are braided stream deposits, how those soils are being deposited, and what type of soils you will see in a braided streams. So braided streams are with a high gradient, which basically means rapid flowing streams. Their velocity is high. Okay, if the gradient of the flow is high, their velocity will be high, so they will be highly erosive as well. If the soil has a high velocity, it will erode a lot of soil. Okay, and it will eventually carry large amount of sediment or particles with it. Okay, because of the very high velocity. So because of this very high bed load, okay, the suspended particles in the water is known as its bed load. Okay, a minor change in the velocity. Okay, if there is a minor change in velocity, if you reduce the velocity of the flow by a little bit, it will cause the sediment to deposit, because its velocity will be no more very high. It will not be able to carry the heavy particles, so it will deposit it in the area where its velocity will become less. By this process, these streams may build up a complex tangle. Okay, the things which are there jumbled together is known as tangled. Okay, so complex tangle of converging and diverging channels separated by sandbars in island. These are sandbars in island, you can see, and these are all the channels. The flow is entering over here and it is becoming braided stream over here, and you can see a lot of islands is being made over here. Okay, just like you can see in the figure over here. Okay, so the reason is because they carry very coarse sediment. Okay, large size particles. They've got high velocity, so they've got a lot of sediment being transported. So when it suddenly enters the open area, it basically loses some of the sediment and deposit them in a form of a small islands, which you can see over here, and the flow is basically going across these. So this is basically a deposition caused by the braided stream. Okay, so now the deposit formed from braided streams are highly irregular and stratification. Okay, compared to the other types of deposits, which I show you the lake deposit, they are over one layer continuous on the top of another layer. But in case of braided stream, they are not horizontally same. You can see over here, this is a cross section. So silt is going this way, gravel is below here, and then above the silt over here. Then you have fine sand, and you have coarse sand below here as well. So their deposition will be irregular. Okay, they will not be in one plane, like one plane of coarse grain, then one silt continues, then gravel, then fine sand. Okay, so their cross section will be basically like a braid. Okay, one deposit moving up and then another down, etc., just like the braid hairstyle which I showed you. Okay, so because of this, the grain sizes ranges usually from gravel to silt, because I told you that they will carry the larger particles like gravels and silt or sand. Clay will not be present. Okay, clay are basically a smallest size of the particle. They are usually not found in these deposits in the braided stream. Mainly you will see the coarse grain particles like silt, sand and gravel. Okay, so although their grain size vary widely, the soil given in a pocket of length are usually rather uniform. Although their grain sizes are very large, gravel is very large size, then you have sand, then you have silt is the smallest size. Okay, out of these three you can see over here. But in a given belt, the particle sizes will be uniform. Okay, like in this the particle size will be uniform, in this the particle sizes will be uniform like this, and here you will have uniform particle size. So it will be unlikely that over here in gravel you have a lot of silt, or in fine sand you have got a lot of coarse grain. So in given deposition belt, the particle sizes will be more or less uniform. You will have same size of the particles. Okay. At any given depth, the void ratio in unit weight will vary over a wide range over a lateral distance. So the problem with the braided stream is that if you have this gravel over here, okay, this is the cross section. If you take a cross section at some distance from here, there may be silt over here. Okay, so laterally there will be a lot of variation. Okay, and this is what we don't want, because when we are building on a particular location, at a particular location, we want the soil to be uniform laterally. Okay, so if you are building on a braided stream, or if you are investigating a braided stream, so at one location if there is a gravel at 4 feet depth, if you are making borehole at another location from there, then at 4 feet depth you may find silt, or you may find sand, you may not find gravel. The gravel will be deeper depth because of this irregular deposition which you can see over here. Okay, so the example of braided stream is the Indus River, near the Indus River bridge on M1 motorway. Okay, this is the M1 motorway, this is the motorway bridge, and this is the braided stream shape look of the Indus River over there. You can see over here it's moving in various locations, and you may have observed the deposition at this particular location, that all the particles which are being deposited all around here, the types of soils, you will see they are coarser particles. Okay, they are silts, they are sands, or they are gravels. There are few clay type deposits in this region, which is usually common in the Sawabi Hond region or in the Hassan Abdal. But in this region you will see there will be coarser particle, there will be gravel, sands or silts, etc. because of this braided soil deposits. Okay. So this is one of the example which I wanted to mention. Now moving to deposition caused by the meandering belt of streams. Okay, so unlike the braided stream, this is not crossing path with each other, this is just following one particular pattern. Your river or stream is following one pattern, but in a shape of like a snake. Okay, so this meander term is derived from the Greek word meandoros, which is basically after Meandorus, which is now Menderes river in Asia. Okay, it's a very famous river. This river is basically famous for its winding course, like it is just moving like a snake. Okay, it's not moving in one direction. The mature streams, the streams which have been there for a very long time, okay, they are known as mature streams, and a valley curve back and forth. You can see it's curving back and forth. First it is curving in this direction, now it is curving in this direction. Okay, you may have commonly seen them. So in the valleys, the meandering is very common. So in a meandering river, the soil from the bank is continuously eroded from the points where the concave shape, okay, and it is continuously deposit where the bank is in convex shape. So when it is moving, the stream is moving in this direction, it will be continuously eroding the soil from here, and it will be continuously depositing it over here. So changing its course from this to more convex like this. Okay, so it will be widening its curve with the passage of time. Okay, so it will be eroding the soil from here and depositing it over here. Okay, and similarly in this place it will be eroding from here and depositing at this location. Okay, so these deposits are called point bar deposits. This is called point bar deposits. Okay. Sometimes during the process of erosion and deposition, the river abandons a meander and cut a shorter path. Okay, the abandoned meander when filled with water is called Oxbow Lake. So sometime during its course, what will happen that the river abandons its path and cut a shorter path, because previously, historically, this river may have this path. Okay, it may have had this path. Okay, like this. Okay, but because of this cutting and deposition, later on it chose to follow this path, which is shorter path. Okay, so this path was basically abandoned. Okay, leaving this lake-like deposit over here, which is called Oxbow Lake. Okay, so you may have seen Oxbow Lakes commonly in meandering river. There are some meandering over here as well, and I can show you this Oxbow Lake type functions over here as well. You can see in the Indus River. So these are referred to as Oxbow Lake, which are usually common. You can see Oxbow Lake over here. Okay, this is basically the previous path of this river, which has now been abandoned and is started following this shorter path. Okay, so during the floods, sometimes these rivers overflow as well into lower lying areas. Okay, this is the path. And during the flood it will overflow into this area, okay, and deposit a lot of soil in this region. Okay, this is the Oxbow Lake, okay, which is the previous path. So this region is known as back swamp. Back swamp, which you can see over here. It is also very common. You may have seen it on the side of Indus River or other rivers commonly over here in a high flood season, in the Kabul River as well, near the Kabul River bridge near Charsata. You may have seen that it deposits the soil outside its path as well, and these deposits are often highly plastic clays. Okay, so this is also very common, and back swamp deposit is also done by the meandering belt deposits. Okay, so they are also very common, and you may observe them in a couple of places. Then number 4, glacial deposits or deposits by glaciers. Okay, the glaciers, which are large pieces of ice, they are commonly moving downward and flowing like streams, which you can see over here is a glacial deposits flowing in Himalaya region. So during this flow, because it's underlain by soil, which is known as glacial till, it is kind of silty soil deposit. So this glacier will take a lot of these silt with it and deposit in the lower area. Okay, so this will be known as glacial moraine and glacial till. There are two types over here. So during the ice age, okay, the ice age was the time when the earth was fully covered by the ice. Glacier covered large areas of earth. The glaciers advanced and retarded with time. Sometimes they were increasing in size, they were reducing in size. So during their advance, the glaciers carried large amount of sand, silt and clay and boulders with them. When they were moving downward, they carried a lot of soil transported to the lower lying areas, which is known as glacial drift. The drift is a term usually applied to the deposit laid down by glaciers. Okay, so the large pieces of ice, they move down and take a lot of soil with them, and then the ice basically it dissolves the water flow and leaves the soil in the lower lying area. The physical characteristics of till may vary from glacier to glacier. Okay, if the glacier is overlaying sandstone, maybe there will be more sandy or silty in origin. If it is overlaying a softer soil like limestone, etc., dolomite, then their tills may be more of a clay in region. Okay, so important definition: moraine is a mass of rocks and sediment carried down and deposited by a glacier. Okay, typically as ridges at its exits or extremities. Usually moraine deposits are deposited at the ridges, at the sides. Okay, while glacial till is deposited in the middle. Okay, till is derived from the erosion and contained material moving down with the ice of glacier. It is deposited at some distance down from the terminal. Okay, so this is known as glacial till. Okay, so glacial till and glacial moraine are two different types of deposit which are transported by glacier. Then number 5th and last one in transported soil is Ulian soil deposits, which is the soil being transported and deposited at other locations by wind action. Okay, so winds are major transporting agents leading to formation of soil deposits, especially in the arid regions or the regions with deserts. When large areas of sand is exposed, wind can blow the sand away and redeposit it elsewhere. Okay, so wind will take the deposit with it, and it will basically take it over the dune, and then the particle will roll and deposit over here. You can see over here in this picture the wind is clearly taking the particles with it and will be deposited. Some will be rolling down here, some will be taken for further distance over here and form very nice shaped dunes which you can see over here. Okay. So the process tends to form a compact sand deposit on the windward side. On this side there will be compact sand deposits because the wind is pushing against this side, while over here the particles are only loosely placed, they are just rolled down and loosely. So if you are sometimes climbing on the milder side of the dune, on this side of dune, you will see the sand will be quite hard, okay, but the moment you come on this side you will see the sand will become very soft and you will just start sliding down. Okay, so on the windward side you will have dense soil deposits, okay, dense sand deposits on this side, okay, and on the leeward side, which is this side, you will have loose soil deposits. Okay, so these are basically uneven soil deposits which are deposition of soil by the wind. Okay, so we have so far discussed two different types of soils, which is residual soils and transported soils. Okay, residual soils are the soils which are found at the location where they were weathered from the rock. Okay, so they are residual soils. Transported soils are the one which weathered at one location but then transported to another location, to a valleys or downstream areas, etc., and being deposited over there, and they were called transported soils. Okay, third type is organic soil. Organic soils are usually found in lower lying areas where you've got more vegetation, okay, on the ground surface, and presence of high water table helps in growth of aquatic plants in those lower lying areas, and those plants then decompose in the same soil and makes it more organic. Okay, so initially this was immature soil, then due to the human activity or due to the agriculture, etc., the organic compound has been increased over here, taken over the original soil and mature soil. Over here you can see that green portion is showing the mature organic soil. So over here this soil is not primarily fragmented pieces of a rock, but this is organic material. Okay, and these organic materials, they are very strong in smell, they are very dark in color. This peat soil, which is commonly known organic soil. Okay, so usually they are not very good for construction, but they are considered good for agriculture or for plant growth, etc. So this type of soil deposit is usually encountered in the coastal areas or in the glacial region where glacial deposition basically occurs. Organic soils show the following characteristics. Their natural moisture content is very high, 200 to 300%. Okay, moisture content. They are highly compressible, okay, because they have got organic materials which can decompose and reduce their volume, so they can be highly compressible, so in turn they can be dangerous to build on. Laboratory tests have shown that under loads large amount of settlement will occur in this type of soil, primarily due to secondary consolidation or secondary settlement, okay, which is basically not good for building, but as I mentioned, they are good for agriculture. So in the coming lecture we will discuss them in detail, their properties as well. So this is the end of your chapter number 1, introductory chapter, okay, in which we discussed the historical perspective of geotechnical engineering, and then we discussed types of various types of soils, and next week we will start chapter number 2, in which we will discuss about particle sizes of various types of soil and how to determine their particle size. Okay, so we will inshallah in detail discuss that. So thank you for watching and good luck.